Hi guys, today we have two main objectives. One is solving absolute functions, and then two is graphing them. On the same slide, you're going to see the tennis ball lab. That's coming up. Sit tight. So absolute value is a number's distance from 0. So it looks like we're using a distance of 5. So that means the absolute value of -5 equals 5, and the absolute value of 5 also equals 5. The reason it's positive is because distances are always positive. So the distance from here to here is 5, and the distance from here to here is 5. The other definition that you might not know as well is that if you square something and then take the square root, so if you square a number, you'll always get a positive number, and then you take it back down to the square root, you will get the absolute value of x. Not as wide known as a definition, I feel like, at this level, but also the definition of absolute value. So when I solve absolute value, some students like to take like the 5 and make it a plus or minus. I like to take the two cases. There we go. I like to show that x could be 5 or positive 5. No, sorry, positive 5 or negative 5. So I could say x is positive, and I can say x is negative. So that when I divide by a negative, I get -5. Okay? When we get into inequalities, it makes life much easier if you solve the problem this way. And then on this side, I want to get the absolute value of x minus 2 alone first before I set up the two cases. So we are going to subtract, I guess 4 minus 1 is 3. So I'm going to subtract 3, divide by 3, and then set up the two cases. Now, I want to make sure I've done this right. There's an issue with this one. Do you see it? The issue, and you could set up your two cases and you might not catch it unless you check your work, but it's right here. Absolute value cannot equal a negative number. So this doesn't exist. So you could say no solution, doesn't exist, DNE, all of those things work. Absolute value cannot be equal to a negative number. So here we have some classic absolute value questions. Again, when I set up my two cases, I do a positive case and a negative case and solve both of those. So if I add 1 and divide by 3, I'm going to get 7/3 on this side. If I distribute this negative, I get -5/3. Okay. Let's see, with this next one, this one's interesting because if I was to subtract the 3, I get a -2, and I just said the absolute value can't be equal to a negative, but if you totally get the absolute value by itself, you get a +2. So just make sure that you've totally isolated that absolute value. So we've got the positive case and the negative case. So x equals -3. And if I add the 5 and divide by a negative, I get -7. So two answers for all of these. 1, 2. Okay. I think that number 3 is going to be more of the same. We just have fractions. Let's look at number 4. So number 4, if I were to subtract the 4, I would get -5x plus 3. Absolute value of 5x plus 3 equals 1. And then divide by a negative. Does not exist. Absolute value can't be equal to a negative. And then we have this interesting quadratic, number 5. So the absolute value is all by itself. So we'll have x equals x squared minus 6. and negative x equals x squared minus 6. We need to set equal to 0 and solve. So subtract the x. And factor. So if you solve that, x equals 3 and x equals negative 2. And then let's work the other side. 0 equals x squared plus x minus 6, which would be plus 3 minus 2. So x equals negative 3 and x equals positive 2. Okay, because we have all of these things happening, we want to make sure we're checking our work to see if that works. So if I were to plug 3 into this, I would get the absolute value of 3 is 3, and 9 minus 6 is 3. So I like this answer. And I highlight it. I like this one. Okay, if I were to plug in negative 2 in for the absolute value of x, of course it won't let me erase. If I were to plug in negative 2, I would get the absolute value of 2, and then I would get 4 minus 6, which equals negative 2. So that doesn't work. Negative 2 is out. If I plug in negative 3, the absolute value of negative 3 is 3, and then I get 9 minus 6 is 3. So negative 3 works. And if I plugged in positive 2, I would get 2 equals 4 minus 6. Well, 2 doesn't equal negative 2, so that one's out. So the only answers that work are the... I haven't used explain everything for a while since last year, so I'm a little rusty. Positive 3 and negative 3 are the only answers that work. Okay, so lastly, we have absolute value of x minus 2. I want to isolate that. So I need to move the 1. And then I'm going to have my two cases. X minus 2 equals positive x minus 1, and x minus 2 equals negative x minus 2 equals x minus 1. Now I'm going to distribute my negative and add the x's to the other side. Add the 1, divide by 2. X equals 3 halves. Oops. Our last big idea for absolute value is graphing it. So if you were to make a table of absolute values, the absolute value of 1 is 1, and the absolute value of 2 is 2, and the absolute value of 3 is 3, and it gives you a V. The absolute value of negative 1 is positive 1, gives you the second part of the V. Okay, and number 2, we've got a transformation of right 3. So I'm just going to take that shape and transform it. Right 3. Number 3, we're going down 3. And I've got my basic shape. So we did some basic transformations. Okay, number 4, here's what I would do. Do you see the transformations on this? Yuck. Instead of doing these simple transformations, we might decide to do what we learned last chapter. Let's just transform our vertex. That's a vertex. Is at 0, 0. Let's just transform 0, 0 to figure out where our point is going to be. Okay, so we'll do 0, 0, and maybe we could do another point to get like the horizontal and vertical stretch and shift. Stretch and compression. So we've got 0, 0. And then to my x values, it looks like I'm going left 1, and then it looks like I'm multiplying by a third, so I'll get negative 1/3. For the y value, it looks like we're taking the absolute value of 0 first, which is just 0. And then it looks like I'm going to multiply by a negative 2, which would also still give me 0. And then it looks like I'm going up 4. So my new point is going to be negative 1/3, comma 4 is going to be the beginning of my absolute value. So let's say that's 1, negative 1/3, 4, is the beginning of my absolute value. Okay, and then maybe we'll transform a couple more points. So let's transform 1, 1. Same idea. So for my x values, I'm going to subtract 1, so I get 0. And I'm going to multiply by 1/3, and I get 0. And then for the y values, I'm going to take the absolute value of 1, which is 1. I'm going to multiply by -2, which is -2. And I'm going to add 4, which is 2. So I have another point of 0, 2. Let me graph that. 0, 2 would be right here. Probably enough info, but let's do one more point. Let's do -1, +1. So we're going to subtract 1, get -2, multiply by 1/3, -2/3. Positive 1, the absolute value is 1. Then we're going to multiply by -2, we get -2. Add 4 will be a +2. So we get -2/3, 2, which would probably be like right here. So there's our new absolute value. I would recommend doing that process when the transformations aren't easy. There we go, little eraser. Because if you look at this, the transformations, gross. So you would have to actually graph this, you would have to change this to make this a little easier on you, -2, and then you would change this to 3x minus 1/3, and then plus 4. So we know that it goes up 4. We know that it's reflected. We know that it's a vertical stretch of 2. We know that it's horizontally compressed by 1/3, and we know that it went right 1/3. I can see all of those things in that picture, but that would have been more difficult than just transforming the points. So good to be able to do both. So that's it for this lesson. There were 2 objectives, being able to, they're both on this slide, being able to solve an absolute value and being able to graph. There are some interesting questions in your homework that I didn't cover in the notes. Not really any of these. This purpley slide, this might be considered one of them, right? So for 16, if we have the absolute value equal to an absolute value, we're trying to see how many times they intersect, right? So if you were to take 3x minus 2 and set it equal to a positive, don't mind my children, 2x plus 7, and then you set up another case, negative 2x plus 7, okay? You might think, well, don't I have to do both the cases for the other side? If you think about it, if you do both the cases for the other side, you would get exactly these 2 cases, except the negative would be over here, which will give you the same result. So you only have to set up these 2 cases to solve this equation. Same with this guy, number 19. Just make sure you pop this guy over to the right and then solve. But there is one that is more difficult than that. The APHL problems you're welcome to try. I might talk about this last one and then we'll call it a day. So we've got 2 absolute values plus a number. So how are we going to deal with this? So I would recommend separating them. So putting one absolute value on one side and one absolute value on the other. So why don't we do B? B, okay. So I'm going to set the absolute value of x plus 1 equal to the absolute value of x minus 1 plus 2. And then I'm going to set up a positive and a negative side for the left-hand side. So here's the positive side. And here's the negative side. Okay, now on the left-hand side, the positive side, I'm going to subtract the 1. And now I only have one absolute value, so I'm going to set up two cases for that absolute value. So I've got the positive side and the negative side. Okay, so the answer to this section is all real numbers because it's the exact same line. Okay, the next section, x minus 1 equals negative x plus 1. If I add the x's, I get 2x, and if I add the 1's, I get 2, so x equals 1 is a solution. Okay, and then I have to work on this side, so I've got negative x minus 1 equals the absolute value of x minus 1 plus 2. If I subtract the 2, I get negative x minus 3 equals the absolute value of x minus 1. And then I'm going to set up two sides, the positive side and the negative side. So I'm going to add the x's and add the 1. So I get x equals negative 1. And if I add the x's here, I get no solution. It doesn't exist. So I get all real numbers 1 and negative 1. Well, what the heck? What does this look like? So if you were to separate these, let's graph this. So I'm going to graph absolute value of x plus 1. Well, that goes left 1. Geez Louise. Looks like this. Sorry, my lopsided graph. The second graph goes left 1. It goes right 1 and up 2. Lands right there. Okay, so where are the values that this actually sits? It sits at 1, and it overlaps all the way this way. So it looks like if we would have plugged in negative 1, it wouldn't have actually worked. I didn't take the time to plug in negative 1 into our equation. I'm going to look at it right now. So I'd get 0 minus the absolute value of negative 2 equals 2. Well, this would be negative 2 equals 2. That's not true. I didn't take the time to plug it in. So the answer that works, it intersects at 1, and then it's an infinite amount of solutions because they intersect 1 and bigger. So try some problems. We're going to have a formative on this on the next time I see you is on Tuesday. So try some problems. Have a great weekend.